Okay, 10-2, day 2 of the arithmetic sequences. Our goal is to find the sums of arithmetic series. So we're going to introduce some new vocab here. What is a series? It's the terms of a sequence that are added together. So we've talked about what an arithmetic sequence was. Now we're interested in adding all of those terms together, or maybe not all of the terms of a sequence, maybe only a certain amount. So we could call that a partial sum, and that's denoted by S sub n. So we're going to look at various problems today in this lesson concerning with the partial sum of particular arithmetic sequences. Now, this partial sum comes with an equation, and it equals the number of terms n times a sub 1 plus a sub n divided by 2. So there are three items that we need. We need the first term, we need the nth term, and we need to know how many terms that we are adding together in this arithmetic sequence to figure out what the sum is. So let's take a look at some examples. Here in the first one it says find the sum of 12, 19, 26, 180. So we have an arithmetic sequence starting with 12, moving on to 19, 26, and so on all the way to 180. That's fine. Our goal is to find the sum, to add them all together. Well, we don't know how many terms there are in this particular sequence. So the note at the top, it says sometimes a1, a sub n, or n itself must be determined before the sum of the arithmetic series can be found. When this occurs, we have to use the formula for the nth term. Now that we talked about on Friday, and that equation is this. A sub n equals a sub 1 plus n minus 1 times the common difference. So here to help us out to to find the number of n terms in this particular sequence, we will use a sub n equals a1 plus n minus 1 times the common difference to figure it out. Okay, so a couple things. We need to establish what the common difference is. From 12 to 19, I'm adding 7. From 19 to 26, I'm adding 7. So I have a common difference here of 7 I can plug in. And I know that the nth term is 180. I know the first term is 12. So let's figure all this out. Let me rewrite it down here. Let's plug some stuff in. The nth term of this sequence is 180. The first term is 12. N is what we are trying to solve. And 7 is my common difference. If I subtract 12 from 180, I get 168. And if I distribute the 7, I have 7n minus 7. And when we solve this equation, we will find that there are 25 terms in this particular sequence that we are trying to add up all of the terms to. The first one is a sub 1, that's 12, and then we said that the nth term there is 180. Now I have everything that I need to move forward with this equation for the series, which is n times a sub 1 plus a sub n over 2. Okay. The sum now of 25 terms equals 25 times 12, plugging in numbers for my equation, plus 180 over 2, and plugging all of this into your calculator. Whoops. Let's go back there. Plugging all this into your calculator, you should get that the sum of these 25 terms is going to be equal to 2,400. Let's move on to another example. This example says find the sum of the arithmetic series, and we have a couple of new items. We have n this time. We know that we're adding 16 terms. in this arithmetic sequence. We know that the nth term is 240, but what about a sub 1? We don't know what that is, so that's what we're going to find first using the fact that the common difference is 8, n is 16, and a sub n is 240. So let's go back to our arithmetic sequence equation, this guy right here, and we can substitute values. 240, a1, which is what we're after, n is 16, so 16 minus 1 is 15 times 8. Solving this one-step equation, we find that the first term in this sequence is 120. So back to the series, the equation for the arithmetic series is s sub n, the number of terms times the first plus the nth over 2. We're adding up 16 terms, so the sum of 16 terms is equal to 16 times a1, a sub n over 2. Plugging all of this into your calculators now. Careful with the order of operations. They come into play big time here. So there you have it, 2,880. Go ahead and verify that, and when you are ready, let's move on. It's your turn. Go ahead and pause the video if you want to, or just keep it playing. I'm going to solve this one and explain what's going on, but by all means, pause it, fast forward it to the solution, and we'll move on. In this example, it says find the sum. We start at 2. And we end at 100. And we need to figure out the number of terms, n. We don't know the number of terms, so let's use the equation for the arithmetic sequence to help find that out. I know that the common difference is 2. It looks like 2 plus 2 is 4, and 4 plus 2 is 6, and so on. And so we say that the a sub n, we say that the nth term here is 100. The first term is 2. N is what I am solving for, and d is 2 as well. 98 equals 2n minus 2. And we'll see that we're dealing with 50 terms. 50 terms in this arithmetic series. So the sum of 50 terms, beginning with 2, ending with 100, is going to be, calculator time, 2,550. In this particular example, our goal is to find the first 3 terms of the arithmetic series, in which the first is 7, the nth term is 79, and we know that the sum is 430. So there are a couple steps involved. The first step, we want to figure out how many terms there are. Makes sense. How many terms are there in the sequence? With that information, then we can move on to find the common difference. Once we know the common difference, we can go back to a sub 1 and we can add it 2 more times to figure out what the first 3 terms of this series will be. So let's find n. N can be found using this equation, which, by the way, will be provided for you guys. And we say that s sub n here is 430. The first term is 7. So n is what we're after, so 7 plus 79, right? A sub n in the equation over 2. And we find that n is going to equal 10. Terrific. Moving on to the arithmetic sequence equation now. I can use this information to figure out what the d is, the common difference. A sub n, the given information, 79. A sub 1 is 7, also in the given information. N is what we just found in step 1. We can plug that in right there. So if n is 10, then n minus 1 would be 9d. In this two-step equation, the value of d then would go on to be 8. And now, if I know that a sub 1 is 7, then guess what? A sub 2 would be 7 plus my common difference, which is 8. We would get 15. And then lastly, a sub 3 would be 15 plus 8 more, and 23. So there you have your final answer. Alright, to the next example. Okay guys, same drill. Go ahead and pause the video if you want to, and try this one on your own. Just fast forward to the solution. Here we don't have the steps listed out for you, so you have to remember, okay, I need to find n first. So I'm going to find n first using this equation. Okay. S sub n, the sum is 5280. N is what I'm after. The first term plus the nth over 2, so the average of these two values. And we find that n is going to be, oh boy, looks like I didn't do this one. N is going to be negative 24 plus 288 over 2. Let's see. 24 negatives plus 288 divided by 2 is 132. So 5280 divided by 132 is 40. There are 40 terms in this particular sequence that we added. And now moving over here to figure out what the common difference is. The common difference is critical because we need to use it to find out the other two terms in the arithmetic series. So a sub n given to me, a sub 1 also given to me. N I just found to be 40, so 39 times d, so 288. Let's solve this equation. Plus 24, 312 equals 39d. The common difference is going to be 8. What a coincidence. So that if my first term is negative 24, then my second term will be negative 24 plus 8, and then the third term is going to be negative 8. And there we have it. Your final answer. Alright, sigma notation. Moving on to another way to portray or illustrate summation. Okay, another way to denote summation, adding up terms of arithmetic sequences, is this thing called sigma notation. Okay, so if we're given a sequence a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 we can write the sum of the first n terms using what we call summation notation, or sigma. This E-looking symbol is sigma. And so the example that's shown there, all right, in fact, let's go over here. Our focus is here, right now. It says this tells us the end with k equals n. So the sigma, here's this E-looking symbol, right? That's sigma. And this number on the bottom tells us where to start. So we're going to start this series with k equaling 1, and the number on the top is where we end. So we go from 1 to n, and we plug these values. Okay, we plug those values into the function that's given to us. So now my focus is here on the example. It says find the sum. So let's translate this. So we're going to find the sum starting with k equals 1 and ending with k equals 5, and we will substitute this into the equation that's k squared. So if k is 1 squared, that's k equals 1 squared. Then we will plug in 2. because we're finding the sum, we are adding these terms. So the first term of this sequence is 1, because 1 squared is 1. And then we're going to plug in 2 squared. Well, 2 squared is 4. And we keep going until we get to that ending number. So I think, hopefully, you kind of get the idea. We get the idea. And so we can say that the partial sum here of these 5 terms equals 55. No different than the equation that we were just using. So here is an example. We want to find the sum of 6k minus 1. That's the equation for this particular sequence, beginning when k equals 4, and we're going to end when k equals 18. So we're going to be using the partial sum formula because it'll make things go quicker. If you think about it, if we start at 4 and end at 18, that's a lot of numbers to plug in. That's a lot of numbers. Particularly, it's 15 to be exact. So instead of plugging in 15 values and adding up all of those values, we could still use this equation. Well, in the equation, what do we need? We need to know how many terms there are. We need to know what the first one will be. Not necessarily plugging in 1 for k. The first one is this bottom value. Where do we start off? The nth term in this equation is where do we end? So the top number there. Okay, so for these summation notation problems, we need n, we need a1, a sub 1, and we need a sub n. Okay, so let's figure this out. The n number of terms, we say, okay, if we start at 4 and we end at 18, that means we had, what, 18 minus 4 equals 14. No. What I want you to think about is if you were to count from 4, beginning at 4 and ending at 18, you would actually be going up by 15. Okay, so I want you to think about subtracting the top minus the bottom, but then you have to add 1 back to it. So 18 minus 4 is 14. 14 plus 1 is 15. That's kind of like if you think about the single digits, 0 through 9, well, you say, okay, well, that's 9. Not really. If you were to count at 0 and count to 9, you would be moving 10 places. So here we are, n equals 15. We know that there are 15 terms here in this sequence, or the ones that we are adding at least. So we look now back into the original equation, and we say, all right, we need a sub 1. That's this guy right here. We'll plug in 4 for k. So 6 times 4 minus 1. That represents the first term in the series. 24 minus 1, so we will substitute 23 in for a sub 1 in my equation. We will substitute n equals 15 in the equation for the partial sum. And then a sub n. A sub n is going to be the 18th term. Whoops. The 18th term. And so we could say that a sub n is the last one. 6 times 18 minus 1, which is 107, I believe. Okay. And so what we need to do now is we need to take these values and substitute them into my equation here for the partial sum. So the sum of 15 terms, let me use a different color. The sum of 15 terms equals 15 times 23, because that's the first term of the sequence, 107 the last, over 2. And let's see what we get. 23 plus 107 over 2 times 15. 65 times 15 is 975. Okay, so just like the previous example, we need 3 things. We need n, a sub 1, and a sub n to figure out what the partial sum is of these n terms. So how many terms are there? N. We said it was 21, top number minus bottom, but remember to add it back. Add it back in. So there are 13 terms in this particular sequence. The first one is when we take 9, substitute that in for m. So 5 times 9 plus 6 is equal to 51. The nth term, 21, plug that in for m. 21 times 5 is 105, times 6 more is 111. At this moment, we have everything we need to find the sum of these 13 terms. So the first term being 51, the last being 111, the average of it. The sum of these 13 terms is going to be, let's see, 81 times 13 is 1,053. And we are finished.